Hi friends, welcome to my YouTube channel. This is lecture number 6 and today we are going to study Silicon Controlled Rectifier. This is very basic topic and very important chapter. You will get at least one question every year from this chapter in your ES exam. First I will tell you some historical background of Silicon Controlled Rectifier. Bell Laboratories were first to fabricate silicon-based semiconductor device that is called Thyristor. Devices like TRIAC, DIAC, SCR, GTO, RTO all have characteristics similar to Thyristor. This whole family of devices is known as Thyristor. Silicon Controlled Rectifier, that is SCR, is oldest member of this family. SCR is also most widely used member of this Thyristor family. At present, SCR is used so extensively that word Thyristor has become synonymous with SCR. So SCR and Thyristor are used interchangeably, means both have same meaning. Now we will go to the construction of Thyristor. A Thyristor consists of 4 layers of alternate P and N layer. This is P type first layer, this is N negative type second layer, here is N negative, this is P type third layer, and this is N positive fourth layer. These all layers form 3 junctions, that is J1, J2 and J3. A thyristor has 3 terminals that are called anode, cathode and gate terminal. This threaded portion is used for this threaded portion. This threaded portion is used for tightening the thyristor to the heat sink using a nut. For better cooling, they are mounted on a heat sink. The rating of thyristor is up to 10 kV, 3000 ampere and 30 megawatt. SCR has these 3 terminals and the anode cathode potential is applied through this circuit and gate cathode potential is applied through this circuit. Here EMF is EG and positive gate current is applied to gate terminal using this circuit. So this circuit is used to get the VI characteristics of thyristor. Now we will study the VI characteristic of thyristor. We will study VI characteristic of thyristor in 3 modes. First is reverse blocking mode, second is forward blocking mode and third is forward conduction mode. First we will start with reverse blocking mode. Name of this mode explains all about this mode. Here in this name, reverse means thyristor is in reverse biased, or we can say that anode to cathode voltage VAK is less than 0. Or we can say that negative potential is applied to anode and positive potential is applied to cathode. When negative potential is applied to anode, then junction J1 gets reverse biased. When positive potential is applied to cathode, then junction J3 gets reverse biased. So in this mode, junction J1 and J3 are reverse biased, while junction J2 is forward bias. In this mode, a very small current, that is order of few milliamperes, flows and it is called reverse leakage current. So thyristor acts as open switch, or we can say that it is in off state during this mode. Now I will tell you one important point. Here N positive region around the junction J3, it is heavily doped as it indicates N positive, and I already told you a heavily doped layer has less width of depletion region extended into it and it has less voltage withstand capability, while this N negative region has more width of depletion region extended into it because this region is lightly doped. So junction J1 has high voltage withstand capability. So when we increase the reverse voltage, then junction J3 breaks easily and whole reverse voltage will appear across this junction J1. If reverse voltage is increased beyond this reverse breakdown voltage VBR, this is VBR. When voltage is increased beyond this VBR, then what happens? Then an avalanche occurs and junction J1 and J3 breaks and reverse current increases abruptly. Here we can see that this reverse current increases very abruptly, and this abrupt current may damage the SCR. So this situation must be avoided. Now we will move to the second mode, that is forward blocking mode. Now in forward blocking mode, also here we have to emphasize on this name. Here forward means thyristor is in forward bias, or we can say that anode to cathode voltage is greater than 0, or we can understand it as positive potential is applied to anode and negative potential is applied to cathode. So when positive potential is applied to anode, then this P layer makes the junction J1 forward bias, and when negative potential is applied to cathode, then this N layer makes the junction J3 forward bias. Junction J2 is in reverse bias during this mode. Here you must note one more important thing, that gate current is equals to 0 during this mode. Now blocking means that thyristor is in off state during this mode, or we can say that thyristor acts as open switch during this mode. During forward blocking mode, a small amount of current that is called forward leakage current flows through the thyristor. This is very small. Now, when the forward voltage, that is anode to cathode voltage, is increased beyond this VBO is forward breakover voltage. So, when VAK is increased beyond this VBO, keeping the gate current equals to 0, then what happens? This junction J2 breaks, or we can say that avalanche breakdown of this junction J2 takes place. When the avalanche breakdown of this junction J2 takes place, then thyristor goes into conduction mode. But such conduction practices are avoided as it may damage the SCR. Now this is last mode, that is called forward conduction mode. Here forward means thyristor is forward bias, or we can say that anode to cathode voltage is greater than 0. Here conduction means thyristor is in on state, or we can say that thyristor acts as closed switch. To make the SCR turn on, we have to apply the gate current through gate cathode circuit. So there are two conditions to make the thyristor turn on. First is anode to cathode voltage must be greater than 0 and gate current must be applied at gate terminal. So now we will understand how SCR get turned on. Let's understand this. We know that during forward blocking mode, junction J1 was forward bias. Junction J3 was also forward bias, while junction J2 was reverse bias. When gate current is applied at this terminal, then what happens? This gate current neutralizes the stored charges in depletion region of this junction J2. Now when these stored charges get neutralized, then SCR get turned on. So here in this characteristic, when gate pulse Ig3 is applied, then SCR starts conducting at voltage VAK. This voltage VAK is less than this forward breakover voltage VBO. So we can say that as gate current increases, then anode to cathode voltage required to turn on SCR decreases. Here, this Ig2 is greater than Ig3. So, when we move here, then this gate current increases. Here this Ig2 is greater than Ig3 and Ig1 is greater than Ig2. So when gate current increases, then voltage at which SCR gets turned on also decreases. That's why as gate current increases, then anode to cathode voltage required to turn on SCR decreases. And once the SCR gets turned on, then gate loses its control. Or we can say that once SCR starts conducting, then it will continue to conduct even if the gate current is removed. To avoid the losses in gate cathode circuit, gate current is removed once the SCR gets turned on. Now I tell you a very important concept, that is concept of latching and holding current. Here in this characteristic, this is my latching current and this is holding current. And we can clearly see that latching current is greater than holding current. Now what is latching current? Latching current is minimum amount of anode current that is required to turn on SCR. Or we can say that anode current must be greater than latching current to make the SCR turn on. Next is holding current. Holding current is the maximum amount of anode current below which SCR gets turned off. Or we can say that anode current must be less than holding current to make the SCR turn off. The questions has been asked directly from these concepts in ES 2015, ES 2005 and ES 2011. So you must remember these 2 points. Next very important point is latching current is greater than holding current, and latching current is 2 to 3 times of holding current. In industrial applications, holding current that is very small, that is typically 10 milliampere, that's why it is almost taken as 0. The direct questions has been asked in GATE 2012 and ES 2004 from this concept. Next is in Thyristor we can control only on state but not off state. That's why it is called semi-control switch. Thyristor can be termed as DC switch. Thyristor are not made of germanium because it has high leakage current. Now we will take some important questions from GATE and ES exam. First is which junction conducts when Thyristor starts conducting? In forward conduction mode, all 3 junctions J1, J2 and J3 conduct. Next is when cathode of Thyristor is made more positive than its anode, then which junctions are reverse biased? In this case, Thyristor is in reverse blocking mode. In this mode, outer 2 junctions, that is J1 and J3 are reverse biased, while junction J2, that is central junction, is forward biased. Next is when Thyristor is in forward blocking state, then junctions are in forward blocking mode, anode and cathode junction, or we can say that junction J1 and J3 are forward biased, while junction J2 is reverse biased. Next is in forward biased portion of Thyristor IV characteristic, the number of stable operating regions are. So there are 2 stable operating regions, one is forward conduction mode and another is forward blocking mode. Next is a Thyristor conducts when it is in dash biased and dash flows. So answer is, this is very easy question, when it is forward bias and gate current flows. Next is, turn on of thyristor takes place when? This is also very simple. Turn on of thyristor takes place when anode to cathode voltage is greater than 0 and gate current flows. In forward blocking region of SCR, it is in off state. Next is, which statements are correct? Thyristor requires turn off circuit while transistor do not. Voltage drop of thyristor is less than that of transistor. A thyristor requires continuous gate current. A transistor draws continuous base current. Here in this, only 1 and 4 are correct, because drop of thyristor is more than transistor, and the thyristor do not require continuous gate current, because once SCR get turned on, we should remove the gate current to avoid the losses in gate cathode circuit. Gate loses its control once the SCR get turned on. So SCR is considered semi-controlled switch because it can be turned on but cannot be turned off by gate pulse. Which statement is correct for SCR? It will trigger when applied voltage is more than forward breakover voltage. Holding current is greater than latching current. When reverse bias, a small value of leakage current will flow. It can be triggered without gate current. Here all 1, 3 and 4 are correct, but second is wrong. Why second is wrong? Because latching current is 2 to 3 times of holding current. I already told you. And here I want to ask you, can we trigger a SCR without gate current? Is it possible? Then answer is yes, it is possible, because when anode to cathode voltage is greater than forward breakover voltage, in this case we can turn on the SCR without applying gate current. So here 1, 3 and 4 are correct, while second is not correct. The anode current through a conducting SCR is 10 ampere. If its gate current is made 1/4, then what will be the anode current? Here SCR is in on state because 10 ampere current is flowing through it. So SCR will remain on even if we remove the gate current. So whether we apply the gate current or we remove the gate current, whether we increase the gate current or we decrease the gate current, it will not going to affect the on state of SCR. That's why 10 ampere will continue to flow across SCR. Now last question is, an SCR from off state can be made on by increasing its anode voltage, increasing its gate current, decreasing its gate current, decreasing its anode current. So here only 1 and 2 are correct. This is very simple question. So that is all about this chapter. I hope you liked the video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.